Right. So I think you are able to see my Excel screen. So this is the file I shared yesterday. And if I see, the first thing is the comma, and the second thing I used concat. So instead of concat, if I use concatenate, this one, and then if I select this, the field length and the comma and the comma, and press enter, you'll get this 2 comma. So uh, Sushma, you got it right, 2 comma 5 comma 3 comma, these
Yes, sir. Yes, sir. I got the first three columns and
and
the
then,
last also, names also. The only the one which is you
right.
derived horizontally, that I was not getting, sir.
Okay, so then you got the panel column using concatenate, right? Not
Yes.
concat but concatenate. So let me use
Yeah,
concatenate
concrete.
itself.
Right, right.
Concatenate, and then press enter, and I'll get the same thing again. That's it. Now coming to what has to be done here, because I have used concat, and some of you are not able to use it. So now I'm writing again concatenate. Okay, so that will, I think, if I choose this 2 comma, all of these, then it will give it in column, right? Not
Uh,
in row.
But sir, I was getting vertically only, but I was getting only one number. When I was copying pasting, you gave another alternative yesterday, na? When
Okay,
this
so
horizontal column.
instead of using concatenate, because we already got it in column, now we can just copy and paste it as by transposing it. So it will come in one row, and then we can concatenate, right? So let me see if that is possible. So uh, let me simply copy them, all of them, all these numbers. So I've selected the field length column, the numbers only, and I have
Excuse me,
pressed.
sir, can you share your entire window, just like you did yesterday when we
But
were not
then
able to see?
it is freezing. If I do like that,
Oh,
it
acha,
will
acha.
freeze.
Okay,
Yeah,
okay.
that was the issue.
I'm zooming from my end then.
Yeah, yeah. Please zoom it from your end. So now I've just copied it, Control C, and I'm clicking any cell here where I want to paste it, and Control Alt V will give me paste as values, paste special uh, box where I can click on values, so it will be pasted as no values as well as transpose, both. You have to select transpose also, because I want it in row, not in column. So let me click OK. So it has come in row, and I'm not sure it will be able to do it like this. Concatenate, and then if I select these numbers, press enter, it is still in the columns rows. So I think this is not working. So forget about this. Let me try to do it in some other way. Okay, let me use text text join function. Then the first option is delimiter. So it should be what? Nothing. And then ignore empty, true or false, it will not matter because we don't have empty. And then it says the text. So now I'm selecting the text. I've selected the entire range, and I got it like this. So that is what you're going to do. Now I'm Control C and then Control Alt V and then paste as values, and it is done. Here are the numbers. Just remove the last comma from here because this is extra, and then do the same way you can do with the names one. So let me allow somebody who's trying to enter. Just give me a minute. Right. So equals text join delimiter is nothing because we already have the commas and everything. If we wanted to delimit using commas, then we would have done it. But commas and quotes, everything is already there, which I'm joining together. Comma next is true false. It doesn't matter whether you write true or false. Any one of these will work because we don't have empty cells. Then the last argument is the text. So I'll select everything, the names, all the names, and close parentheses and enter. And again Control C and then Control Alt V and then paste as values, and then double click it and then put this extra quote at the very beginning, and then this remove this last quote and comma, enter, and I got it as it is required. I hope it makes it clear now. Sushma,
Yeah, yeah. So if not concatenate, use text join.
use
Uh,
text. Yeah.
I'll try at home, sir. I will not waste time today doing this. If I'm not successful,
Yeah,
I'll
you
take
can
the
get
help
back.
tomorrow's class, sir.
Please get back to me. I think it will work 100%.
Hopefully, sir.
Okay, so this is done. I'm closing it. Uh, Now the second thing, which
So we should
yes,
also try this one also only because for us also contact net was not working.
what are you saying? Should I what should I
So
do?
yeah, so you told about this text
Yeah,
thing, no? So we
yeah.
should also try that only.
You can try that. If Concat is not working, you can try
Yes,
text
sir, that
join.
is not working. I did the copy paste from yesterday's class. It
Okay,
is not working.
okay. So I'll do one thing. I'll share this Excel file again on WhatsApp.
Sir, and the command also, sir. This text join the format that you're doing, na? Text join bracket
This
difference.
Excel that I was working on, I saved it actually. So
Okay.
when I share it with you, you can see which formula was used.
Okay. Okay. Thank you,
Okay,
sir.
sir.
Okay, so next is some little visualization on the data we
So,
imported
so
yesterday.
I shared my command with you. Just
You have shared it? Okay.
yes, sir.
Well, let me have a look at that first. .r, yes. So let me open this up and see what can be done. So, so this is your file. So you put in HH level, read after FWF file, see HHV1.php,
Yes,
break
sir.
this. Oh, it seems good to me. I,
Yes, sir. And actually I crossed it like multiple times. Then I found like, is it problem with the text file, or is a MacBook issue or something? Because we read FWF file, not a text, because it is saved in text file. So is that it can be a
no,
issue?
no, that's not an issue. That's not an issue.
Okay. Because I'm not able to view also. There is only one text file on this name. I have checked the entire
No, you
documents.
will be able to view only if R is reading it. And okay, see, why are you viewing this text file? You have to view HH level because you saved it as HH level. Now you have to view HH level actually.
Sir, can you just do little left of your screen?
So let me use the same code to do it again.
Sure,
I
sir.
have not edited anything,
Mm-hmm.
and I'm using your code only. And I'm running the line. So it's working. So was it happening with in your case also that there was a red button for quite some time here?
Sir, can you just do a little left of your screen because I can't see beyond
No,
left.
actually you have zoomed it in, so you have to do it.
Okay, okay. Oh, sorry, sorry. No, sir. Still, I'm not able to see. I zoom out it. Okay, now I can see. Sir. View HH level. Okay.
So now you see that this red button is coming. I'm running your file. I have not edited anything except the HH level here. So it is working because this red button is there. Now, as long as this red button in my
In
console is there, it's working. I
HH
have to wait
level.
for some time, and
H.
then I will
So I
run.
have to run HH level first.
No, no, no. Yeah, HH level, the first line first, and the fourth line next. Run the first line first.
Sir, same error. RT file cannot open.
You got the error. See, my R is working and it is searching for this. I mean, it is working on it and it is importing it. So your command is perfect. It's something to do with your R Studio, uh,
Sir, what
and
is it? File RT, small RT, inverted comma.
this error has to be checked online. That what does this error mean and
Online
why?
is showing saying sir the path issue, but I checked on chat gtp. It is showing that and also it is saying that ki hh level object is not found. And
Yeah, that is for line number 4 because you are viewing something which is not permissible to open.
chat, yes, chat gtp said that you have used full path. So I also tried full path. I copied the path and pasted it instead of the file name. And then it asked me for correct working directory. Check the correct, the two things it suggested. I tried both.
Okay. So did you try any importing any other data set? Were you able to do it? The
Yes, sir.
importing?
Earlier every data was working, sir. Earlier you told me the excel format, it was working. Text file, and first time I'm trying.
So let us uh, try it and get back to me later again
Sure, sir.
because
Sure, sir.
nothing can be done at this moment.
Yeah,
Nothing
definitely,
is
sir.
coming to my mind. Right?
Okay, sir. Okay, sir.
So let's leave it here and we'll sort it out later. But in my art, it is working. So the code is fine. Code is good. So anyways, I'm importing it again because I have to show the visualization thing. So it will get imported in a
So
minute or
just
two.
one request can I put, sir, for today's class?
Why not? Why not?
So I think we have done enough of the visualization. I wanted to stick to the topic today that you have selected for today
So
and today's class.
I will come back to the topic. Just somebody asked it, so let me do it for
Oh,
15 minutes. Yeah.
Okay, okay, sir. Because
15.
I really wanted to do this multiple regression dynasty test and tomorrow logistic. And if we get some time visualization, so we can keep on doing some. It's trial and error, I guess. You have to keep on doing all this.
Okay, so just a little bit we will do. So and then we'll move to regression. So it's done. Now I'm clicking view HH level and I can view it. So it is there. Okay. So yesterday we did a histogram, right? And that is in the yesterday's code also. So I believe you all would have run that code and got the histogram, right?
So it worked.
Yeah.
I did the copy path, the file from working directory, and then now it working, sir. View
Oh,
it.
great,
Yes, sir.
great, great,
So
wonderful.
direct CHHV1 text file was not working, but copy path is coming like desktop has
Yes,
this
yes, yes.
folder, then within folder we have this file.
Great, great.
Thank you, sir.
So whenever anyone faces some challenge, it's better to try it 2 3 times this way or that way. If you are missing something, you'll be able to sort it. You can go online to troubleshoot. Actually, I was having in mind some questions that were asked before also regarding visualization. Somebody asked how to use color. Somebody asked some uh, regarding the palette and all those things. So let me start with the color thing because it just struck my mind that I was asked that question. So I will because there are 9 categories of religion. Uh, I'll be using these variables. Let me show you the variables first. So all of these state code, this, that, it's difficult to use in visualization. So let me use some quantifiable variables. One of them is religion. And then let me use this household, not type, household size. So how many people are there in the household? Religion, social group, 3. And then these are the consumption expenditures for this purpose, that purpose. And at the end, there is a column which says monthly expenditure, total household usual consumer expenditure in a month. So that is the sum total of the other 5 columns. So I'll be using this column. So this column, household usual consumer expenditure, then the data in social group. In social group, there is a 1, 2, 3, and 9. 1 is SC, 2 is ST, 3 is OBC, and 9 is other. In religion, there are 1, 2, 3, 4, 5, 6, 7, and then 9. So there are a lot of religions. I want to cut short to 3 4 religions only. So I'll filter the data. Only those rows I will select which belong to religion 1, that is Hinduism, religion 2, that is Islam, religion 3, that is Christianity, and religion 4, that is Sikhism, or maybe up to 3 only. Because then we will be able to see. Otherwise, there will be many colors on the plot, and Uh, it can be done, but if it is required, using the same type of code and reasoning. Then household size is our number. So I'll treat this not as a categorical variable, although all of these are integers. So number of people in the household. But religion I will treat as categorical. Social group is categorical. Household size is continuous, although integer. And then consumer expenditure also continuous, right? So let me use these variables for just plotting 2 3 graphs, and then we'll move on.
So just one query. We have already imported this data set, right?
Yeah,
So for today, what we need to do? Again, we need to run this command HS
of
level.
course, of course, you have to import it again.
Achha. So the
Yeah,
same command household level
yeah, yeah.
slash rate.
Same,
This one.
same.
Sir, I'm using the same page. Do I need to? I don't need to do anything again, na?
If your R was not closed and you
No, no,
did
no, no, no. Mine was not closed.
not closed, so just run line number 4. If you can see the table coming, then you are good to go. Just try line number 4. If it is showing the table after running this line, then you are good to go. Otherwise, you have to run all the way from line number 1. So I have done this. I'm calling it my data, and I'll use the filter command. This my data will be a subset of the entire data set, and the data frame is HH level, and I'm asking for region less than 4. That means 1 2 3, only 3 of them. I've run it. Now I can view my data, and this is my data. The only difference between my data and HH level is in my data there are only 3 religions, and in HH level there are 9 religions, right? That's it. So I filtered the data. Okay. Now let me. Yesterday we did the histogram. So doing the okay, I have to library the ggplot also. Ggplot. The data that I'm using is my data, and I'll be using household consumer expenditure, household usual consumer expenditure in a month. This one, and geom histogram, right? So if I run it, I'll get the histogram. So in the meantime, because it's a big data set, so it's taking a lot of time to plot the graph. Okay, so the first thing that we observe is that the bars are quite broad, right? And the we can be we can see it minutely by increasing the number of bins, because we have a big sample, 1 lakh sample. So 1 lakh sample size, you can increase the bins to 100 or 15, at least 50 we can do. So I'm increasing the number of bins, and oh, it will take a long time again. No, it did not take that much time. So this looks better. You see the breadth of the blocks or the bars has decreased, so it is more. Or if I take 100, it will even look better. You will be able to see the uh, you know histogram better. So remember, whenever you do a histogram, you have to select the right number of bins. It depends on how big a sample you have. The more the bins, the better it looks. But again, it is your choice how many bins you want to use. Okay, now I am, because it is all black and gray. I want to use another variable, religion, to be displayed through colors, right? It is a histogram of consumer expenditure, monthly consumer expenditure of the people in the sample, of the households in the sample.
Sir, I want to clarify one thing. Sir, this the ninth line, this is household dot s dot usual. You have copy pasted it.
Ninth line.
Ninth.
No, I
You have
just wrote.
written.
No, I wrote HOUSE, and when I did that, it came itself, and then I was able to
Okay,
just
fine,
click
sir.
on it. Yeah,
Fine, sir.
I didn't type the entire line, just the
Okay.
first few words I typed.
Okay.
Alphabets. Okay, now we can see the color, right? So there are three colors, and one means Hinduism is red, and then green, and then blue. So these colors are assigned by R automatically. Some palette was chosen. There were the requirement of three distinct colors on the basis of religion, and we found that. Now this is a stacked bar histogram. Stacked means that the bars are sitting one over another. So we can see the distribution, comparative uh, density or count or number of households in Hinduism, Islam, and Christianity that have a particular average monthly consumer expenditure. So there are very few of them here, and then for Islam it's more than that, and then for Hinduism it's lot of families, lot of households. It's because the population is such, in India. So that's all what we see from here. The next thing that we see is the distribution is close to normal. So there are few people in the tails, few households in the tails, and there is some center where most of the households are there, and therefore there is this peak in the middle. So when we have a peak in the middle, we can say that the distribution is normal. Okay. Now another thing is that
In this graph,
yeah,
yeah, in this histogram, can we mark out the mean in terms of that
yeah,
that bar?
yes,
Yeah,
we can mark that out. So let
minimum
me,
mean either way. Yeah.
yeah, we can do that. So I'll do that in a moment. Let me first do one thing, that there is a lot of space on the right hand side. There are some households in the very extreme right also, but we can't see them, right? Because they are very less as compared to these numbers 7,500, 5,000. Maybe there are 3 4 households here, so that can't be seen. So I just want to limit the x-axis. So I'm doing x limit from 0 to 40,000. So if I do it, then the x limit will be reduced and we will be able to see it better. So here it is. For giving the labels, you can use the labs command in another layer. I'm adding another layer by using a plus sign.
Sir,
And
I have one doubt. So,
yeah,
what does one signifies? The pink color, green color. I mean, where can I find the information that tells this is significant? This is indicating this thing.
Hinduism and Islam and Christianity.
Yes, sir. One,
Okay,
two, three.
okay. So because if you see the religion column in the data, so there are numbers 1, 2, and 3. So one means Hinduism, two means Islam, and three means Christianity. That you can see in the instruction manual
Okay,
where
okay,
where the codes are explained,
okay.
right? Although I can put here explicitly in the graph because the readers might not go and see what is what. So I should, instead of 1, 2, and 3, I should have Hinduism, Islam, and Christianity written here,
Okay.
right? For anyone who has a look at this graph must know what is 1, what is 2, what is 3. You can't tell that person, okay, go and look at the instructor's manual.
Yes, yes, sir.
So that is a good point that you raised actually.
Yes.
So I'll do that also. Now first let me put the title, histogram of monthly consumer expenditure by religion, because we can see the color also, and color tells us where is what religion, right? So this will be the main title. Within this labs uh, layer, you can do a few more things. Like somebody asked me when I was doing that visualization, that if the units can be placed somewhere. So here also the x-axis name doesn't. It's sort of long, and uh, I should make it more presentable. So the the only thing that you have to write is what should be the x label. X equals to what you want to put there. So I want to put consumer. Let me put monthly consumer expenditure. I'm writing CE because to save time, and then RS because it is in rupees. So now the unit is appearing, right? So that's what I wanted to show. And then similarly, instead of count on the y-axis, you can write something else, maybe frequency, right? Just for the sake of doing it, I mean, it's a good idea to put frequency instead of count. So let me just plot this one. Okay, now you can see that unit and everything, and you know the labels arranged properly, right? Uh, okay, now let me come to the color thing. So I'm adding one more layer plus, and that manually setting the color, it can be done by scale underscore fill underscore manual. And now you can give the colors in the form of a vector. So orange, orange, green, and let me take purple for Christian. So and let me so of course this factor religion is also not looking good there, because what is this factor? So let me call the name also. Name equals religion, right? And let me put the labels also. Labels, not labels. Labels equal, and then let me put a vector of 3 labels that I want there. So I want Hinduism, Islam, and Christianity, right? Let me run this. Let's see if the changes that we wanted are coming. Insufficient values in the manual scale. 3 needed, but only 0 provided. Oh, where did I do that? I provided 3, right? Orange, green, purple. And then, okay, did I use the data right? My data is fine. Okay, let me remove this line and let me remove the labels also. Maybe this is creating trouble. I'll do it again. For now, just the colors. Oh, it's a problem here itself. Okay, let me see how many religions are there. My data dollar unique UNIQE my data religion 132. So I'm good here, I think. Okay, 132. Oh, why it is not coming like that? Because this converts into the color, right? Okay, what about if I write the code? Okay, you have to write the code of the color actually. So these codes can be gotten from some um, you can visit the R Studio website and then there you will get the cheat sheet codes for all colors. And in scale fill manual, you have to provide the colors codes, not the color names. They won't work.
So with color it is working, but uh, uh, before C, I am using values equal to
Oh,
C,
again it's happening.
then color. So it is working. So,
Where?
sir, C manual, then the bracket before that values equal to C, then orange, purple, and this. Then it is working.
Okay,
Value.
values. Oh, right, right,
Yes.
right, 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 right. Right. Very good. Okay. Oh, exactly. It's working. I just forgot this value part, and I thought maybe I have to use the code. All right. So here we go. We have our graph and with the colors that we wanted, right? So you have to write in any graph scale fill manual and then values equal to C and put the colors. You have to put exactly the same number of colors that are required. So if three colors are required, you have to put three colors in this vector. Right? Now I can change that 1, 2, 3. Let me change this 1, 2, 3 to labels. So labels equals C and then Hinduism, Islam, and then Christianity. So these will be the labels. So we got the labels as we wanted. Uh, you can adjust the size, the type of text, the position of these x-axis labels, y-axis labels, and here. Okay, let me do one more thing. Write names equal name equal religion, because that would change the heading of the label instead of factor there, which was not looking good. So that's the histogram. Uh, so we can do more this thing, but it's already 8 o'clock. So let me stop here and let's go to regression now. Otherwise, less time. We already 45 minutes are gone on this. All right. So how many of you are aware of the basic regression? Please raise your hands. You have some knowledge of what is regression and what are standard errors, or what are coefficients, and what are p-values, and what are confidence intervals. Just these basic things about regression. Uh, Please raise your hand so that I know how many of you have this basic understanding of what are coefficients, what are confidence intervals, what are standard errors, what are p-values. So raise your hand. This is important for me to know it, because where from where should I pick this up? How much time to devote on what part? It will depend on these answers. So I've got 1, 2, 3, 4, 5 hands raised. 5 people. Okay, more are coming. Please raise your hand. 1, 2, 3, 4, 5, 6, 6, 3, 4. Don't unraise them. Just keep raising the hand. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of you are aware, right? Okay. Then how many of you are not at all aware of these things? Raise your hands. Not at all aware of any of these things. Those who were raising hands before, they should put their hands down. And now those who have no idea whatsoever about regression. Chitra, please put your hand down.
So meanwhile, can you keep sharing your R script? Is it possible? I was trying that histogram thing.
Okay, okay, okay. So 1, 2, 3, 4, 5 people have no idea about regression. Okay. So I'll give 5 to 10 minutes a basic overview of what is regression, and then I'll start doing it practically. All right. So regression is a method, a statistical method, which can be used to ascertain association between variables. In other words, suppose you want to know whether or not uh, experience, or let me say education, affects salary. That means if somebody has got more years of education, that person will have higher salary, and the person who has less years of education will have a lower salary. Uh, is that the case, that there is some correlation going on and some association is there? If yes, then if you raise education by 1 unit, on an average, how many uh, rupees the salary will increase? If you are interested in knowing this number, you have to go for regression, because if you take the two variables and then put them in this method regression, run the regression, you will be able to get that association, or that if 1 unit change in rise in x leads to how many units rise or fall in y, you'd be able to see that through regression. Now there is a lot of there are some assumptions which have to be met uh, regarding the data. So those assumptions are important, and there is a way to check those assumptions, which I will show, and then I will run the regression and calculate these coefficients. The coefficients are those numbers. For example, if a unit rise in education leads to a 5,000 rupees rise in salary on an average, this 5,000 will be the coefficient of education. Now, if salary depends on education, then salary is the dependent variable and education is the independent variable. In regression, there is this direction that education affects salary, but salary does not affect education. If we are if we are assuming this thing, we are considering salary to be the dependent variable and education to be the independent variable. Now, for one dependent variable, there can be many independent variables in the same regression. So you might argue that the salary that a person is getting, it not only depends on years of education, but it also depends on experience in years. It also depends on the person is a male or a female. It also your salary would also depend on uh, how many kids you have. Your salary will also depend on maybe what is uh, the amount of expenditure that is done by the government in your area. So there can be many factors. Uh, they will all be independent variables, and then salary will be the dependent variable because salary depends on all of these things. So there is one dependent variable, and there are multiple independent variables, and we check the effect of independent variables on the dependent variable, and we quantify that effect through regression, right? So that is the statistical method. For that, we need to have data, and we need to run this method, this regression, and then we need to interpret the coefficients and see their statistical significance also, right? So let me use that teacher salary data because I am talking in that context. So let me import the teacher salary data first. You have that data. You can also import it. Uh, if are you facing difficulty in importing that data set? Just try it. I'll give you 2-3 minutes to do it. Uh, if yes, then I will share a CSV file. I'll write a CSV file using the same data because that is easy to import. Because the file that I shared is Excel file.
So is this possible to use the PLFS data that we extracted yesterday to do this multiple regression thing?
Yeah, it is possible. We can. Should I show you in
So
that data only?
yeah, if it's okay with the other participants.
Okay. What about the other participants? You able to import this PLFS data correctly? If yes, then we can show. I can show you using that data only.
Sir, I was not able to import that data properly.
Okay. So in that case, you can can you import any other file that I shared? Any file would do it. Just that you have to see what variables are there, and you can use those variables which are there in the data that you imported. If that is the case, otherwise I'll share a
Yes, sir,
screen.
like teacher salary I have imported.
Okay, so people were facing difficulty in importing the Excel data. So let me do it very quickly. Because CSV will be easy, I think. Let me find another data set that has. I think the best thing will be, rather than importing the data set, let me use the already existing data set in R. So all of us can do it. What do you say?
So whichever is feasible for everyone, but
Hmm.
at the end, just show me how to do the analysis. Means if it's this time the PLFS dataset that we worked on, and how do we extract the how do we use the data using a large data scale? That is the only motive to use PLFS dataset in order to do the
Okay,
analysis.
how to analyze the PLFS data? That's what you're saying.
Yeah, yeah. When we do go for this logistic regression or multiple diagnostic or multiple regression.
So
So
you want,
it's a large data set, right? So with so many variables, right? So
yeah,
if you want to put some regression, that's why, because the data that you have shared, this is a very simple data set, isn't it?
yes, yes,
Yeah,
yes.
that is the only difference between using why I was asking you to.
Okay, but it hardly makes any difference whether the data set is a big or a small data set because the command will remain the same, and you don't have to do anything. All the work is done by the machine. You don't even
Huh.
feel that.
Okay.
All what you have
Okay.
to write in the code is the name of the variable,
Huh.
and that's it. So if it's a big data set or a small data set, it's the same for us.
So
But
in that case, how do we choose the number of variables, sir? Then you 129 was the case, isn't it? When we use the household data set yesterday, when we were using the PLFS data set.
129 characters were there
Achha, sorry, characters.
in that. Yeah.
Variables were on the left column, right, sir? Some 20 or 30 column.
Yeah. Okay, so let me share my screen. So there is this wage data. These are the data sets that you can see on my screen, which I shared with you, right? So I'm just clicking on that particular data set. You can follow my instructions. Just save the data sets that I shared with you in a folder. Set that folder to be the working directory, and then go to files, and you will see all of those, right? So
So where do we need to go? We don't have to import all this data set.
no, I mean you can import it from here only. Like click on it, import data set, and
So how
then
did you get that portion on the left hand side, all this thing?
click on files, files. So I have imported the data set, wage function. This is the data set. 1289 rows and 15 variables. How many? Eight variables. So what you have to do is go to the session tab, set working directory, choose directory, and select that folder in which your data sets are there, right?
Got it, sir. Then we need to import it from there.
You just click on that any particular data set and
Two
you'll be able
options
to
are there.
import.
We need
So
to
when
import it.
yeah, you just click on that, it will import it.
Okay.
Then click on import data set, and when you click on import, you will see the code preview. Code preview. You can simply copy that, all three lines. Copy those lines. Control C. Can you see on my screen the table? This code preview.
Mm,
Yes.
so
So
I can see that.
I'm copying it.
What's
So I don't have to write these commands. I can copy them from here. Come back to click on import.
Sir, I
And
have
this,
one doubt. When I'm clicking on import data set,
yeah. Can you
it
revise it, sir? Yeah.
is saying download the package. So should I download it right now?
yeah,
Does it
download the
take?
package. Download the
Okay.
package. The package has to be downloaded, and
Yes.
then nothing else has to be done. No need to library. No need to write the command.
Sure, 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 sir. Sure,
It
sir.
will appear automatically. Just copy it from there
Then
and
we
paste
can
it.
browse. Yes, sir. Yes, sir.
So
Copy
can
and
you repeat it?
so click on file, file plot package help.
Okay. Then we copy the codes.
Then click on any particular file that you want to do it. I am doing it using wage function. Just click it, and you'll see import dataset.
Oh,
Then from here, it will be showing you how the data looks. So it looks just fine. And then just copy from the code preview the three lines of code. Copy
And
them,
then we can
Control
paste
C.
it.
Click on import. It will be imported,
Mm.
and then go there in your R editor, Control V, so you'll get the code. So you don't have
Yes,
to,
yes,
you
yes,
did not
yes.
write this code. It was
Mm.
automatically
So
you put.
this is much more convenient way.
Yeah, this is much more convenient way, of
Mm.
course. Yeah, but in the beginning, I wanted to
Yes, yes, yes. Got it,
uh,
sir. Got it.
write it so that you get used to it.
Hang of it. Yes.
That what is actually going on. Anyways,
I get one file at one time, but you did it all together. Can you repeat it how you did it?
I just I put all the 4, 5, 6 files in one folder, and then that folder I've set as working directory. Then if I click on files, it will show me that folder only.
So, but in my R files is not coming. The option file is not coming.
At the top, you can see this file tab,
No, sir. No,
file
sir.
tab.
No, sir.
Do you see plot, package, help, everything?
So in my oh wait, sir. I have to cancel. Environment, history, connection, tutorial. That's it, sir.
No, that is another tab. Look at another tab. There are four. There are four panels. That's not the panel that I'm looking into. There is this another panel.
Okay, sir. Down. Yes, sir. R. Yes, sir. Files. I got it, sir.
Yeah, click on
Then
files, tab,
files.
and you'll see that all those files.
Within files.
Within files, you can just it will open that folder only that you have set to working directory. So in that folder, you put the file, so you can see the files.
From desktop, yeah, I can see the desktop. Then from desktop, all the folders.
Now go to that folder in which the that file that has to be imported is there.
So within file, I can see everything that I have on my desktop.
So that particular file wage function, is it on your desktop?
Yes, sir.
So click on that.
So on desktop, I went to working directory, but
No, 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 no. Can you locate your file here in this panel?
not like this, sir. In working directory, I have other files also. I have saved it.
Okay, let it
It's
be.
coming like that, but other files also are
No,
day
let
one,
it
day two, day three.
let it be there. So how does it matter? You need wage function. Just click on it.
Base function. Okay.
Yeah, click on wage function and import it. Done.
View file, import dataset. Yes, sir. Done.
That's it.
Okay, sir. Okay, sir.
Okay, so now we have this wage function. Uh, I can replace it by my data also. So if I do it like this, it will be saved as my. I've run this line. Now it is my data, not wage function, but my data, because this left hand side is some name given from my side, and here also I can change my data if I want. If you don't want to change it, you can keep it as wage function. Doesn't matter, right? I have done it to my data instead of wage function, right? So let me start with model. Let me see the names of the variables first. Names, my data. So observation, wage, female, non-white, union, education, experience, age, and these are the variables. So what is the wage of this person? 11.55. The person is a female because female is 1. Otherwise, if it is a 0, the second person is a male. The first person is a female. Then the first person is non-white. That means the person is black. So it's a black female actually. And then the second person is also, sorry, the person is not non-white. So, so that means the person is white, right? The first person, the second person, the third person, the fourth person is non-white, because non-white is 1 means the person is non-white. If non-white is 0, that means the person is white, right? Then union, the person is a part of labor union. If yes, the person shows 1, and those who are not part of labor union, those have values of 0. How many years of education? So first person has got 12 years of education, 20 years of experience, and 38 is the age. So let us have a look at the types of variables that we have here. We have wage, it is continuous. Female is categorical with 2 categories, 0 and 1, where 1 is female and 0 is male. Next is non-white, it is also categorical with 2 categories. where 0 is white and 1 is non-white. In the in next is union, 1 is union, 0 is non-union. Then years of education, those are numbers. Years of experience, those are also numbers. Age, also numbers. That's the data that we will use for regression. So what might be your hypothesis when you see this data? You would want to check what are the factors that affect wage. So somebody has a high wage, somebody has a low wage. Does it depend on that those who are females have lower wages, those who are non-white have lower wages, those who are not in union have lower wages, those who have less years of education have lower wages, those who have less experience have lower wages, those who are less in age have lower wages? We want to see that, right? So wage is the dependent variable, and female, non-white, union, education, experience, age, all of these are explanatory variables, or they are independent variables. So we are going to do a regression of wage on female, non-white, union, education, experience, age, right? So then we will be able to quantify the effect of the independent variables on the dependent variable, which is wage. I think I made myself clear what I'm going to do. Any question on this, the theory part?
No, sir.
People are silent, so how do I take it?
No question, sir.
No questions, sir.
So I want to understand this. After you define base function,
Yeah,
then is it necessary to save it as view my data? You again define it as a my data for a first base function,
not
then my
necessary.
data. Again, view my data and names. It is necessary to do that,
Not necessary.
or we can directly.
You can keep it as wage function. But
Okay, sir.
wherever I am writing my data, you write wage function. That's it.
Okay, sir. Okay, sir.
So
You know
I
what?
did just that my data, but it was taking the previous my data thing, like the
Oh yes,
PLFS data. So I again renamed it as wedge function only because it was not giving me that thing.
you can rename it as my data one.
I was thinking of doing my data one when I thought let it be wedge function only. So I switched to again to that.
Okay,
But then you
so
sir, you had said that if you do something like that, it overrides the previous thing.
yes,
You had mentioned that, no?
definitely it will overwrite it. If you do it once, if
But
you run
why?
that time,
But why did not it override this time? I was just wondering. That's why I didn't ask you.
so that you have to see why it didn't do that.
Yeah, yeah. No, sir. I'll do it on my own free time. Now time is limited.
Yes,
Let's utilize the optimum.
yes, yes.
Mine has already overwritten the earlier data.
So it overwrites. If
Yes, sir.
you
It already overwritten, sir.
okay. In the meantime, if I forget, let me make an announcement. Tomorrow is the last day of our workshop. So I would request all of you to be on camera for a minute so I can click a photo for records. So tomorrow I'll do that. So please do it.
So, so please don't upload it then on networking sites.
No, no, no.
I
I don't.
just
I
keeping
will
it for
not.
records only, na? Yeah, yeah. Okay, fine.
Yeah, I will not upload it, but I'll have to put it in some report regarding the workshop. We make
Okay,
report at the end
okay,
of the
okay.
workshop that
That's
how did
fine,
it
sir.
go.
Okay.
So in that I have to put up some photos. So I'll take 2 3 pics.
So, but in case you want to upload, then I'll keep my camera off, and other participants you can
No,
do
I
it.
will not upload it anywhere. No, that will not be done.
Okay, sir.
So
Thank you.
rest assured about that. Okay, so coming back, let me run the regression. So the regression command starts from some name that I have to give. So maybe model one, maybe model wage, whatever name you want to give, model wage. It's a wage model, right? So I'm writing model wage. And then starts with LM. LM means linear model, right? Linear model. The first argument is the formula. So the formula is that wage is the dependent variable. So you write the wage, the dependent variable first, and then put the tilde. This tilde sign is there just below escape key on the top left corner of your keyboard. You can press the shift to make it appear here. This tilde sign. After the tilde sign, you can write the independent variables. So the independent variables I am taking right now is education, and you have to write plus experience, EXPER, that is the name of the variable in the data set. Then age. I have taken three variables here, and then I'll put a comma, and then I'll put data equals and the name of the data set simply. So that is my data. For some people who have not changed it to my data, you can write wage function or whatever the name was and run it. Now this regression is run. Next thing that you have to do is to write summary model of the name of the model, whatever the name of the model was, model wage, and click enter, and you'll see the output, right? So this is the regression output. It has the formula, it has what variables are there that have been taken into regression. Then it has residuals. So residuals are, okay, let me not go into it right now.
Sir, the regression line is not visible.
Uh, this line number 24 is not visible.
Yes, sir, in the bottom console.
Yeah, I have to scroll it down to make it.
No, I did exactly same as yours, and mine is coming model way. Just repeat the same line is visible in the down console. But this formula line is not visible.
So you have to write line 24, line 25 both.
Oh, okay, okay,
Sir,
okay.
age is coming as a NA.
Yeah, age is coming as NA. I'll see to it. I'll see to it why it is coming as NA. So I think you all got this result,
Excuse
right?
me, sir.
Yeah.
Sir, it is showing model wage not found.
So did you write this wage and everything like this? My data is the data set.
Yes, sir. In my it is wage function, so I have written wage function.
Okay. So it should show. What about others?
So I got it now.
Okay.
Got it, sir.
All right. Okay. I think in this case, if I want to diagnose why I am getting this NA.
Yes, sir. Seems like it has dropped the age variable. Multicollinearity, maybe? No.
Okay, let us drop this for now. Let me not go into looking into what happened there, otherwise we'll lose more time. So I'm running the regression of only two variables, education and experience, right? So now my hypothesis is that does education affect wages? Does experience affect wages? Now the first thing that we see is there are stars here, three stars here, three stars here. And then we have these p values less than 2 into 10 to the power minus 16. So it is equal to 0 actually. So the p values are very small numbers and having these stars. So when p values are small, we have these stars. These stars mean that these variables are significant. So education is significant, experience is significant. So when I say significant, what I mean is that education is statistically significantly affecting wages. Had there been no stars here, we would have concluded that that particular variable that doesn't have stars at the very end uh, is not statistically affecting wages. But here, both the variables, education as well as experience, have three stars at the very end, and the p values are very small. They mean the same thing. If p value is small, there will be stars. If, if there are stars, the p value will be small. So one of these two can be seen. So what does this mean that education significantly affects wages? It means that education is a factor, uh, is a reason why wages are more or less, right? Similarly, we have experience, right? Now, coming to estimate, standard error, and t value, three things are there. This estimate 1.41452 is an estimate of the population parameter uh, that captures the effect of education on wage. We call it estimate because we are what the regression that we are running is based on sample data, and 1.414 is a sample statistic, but we are generalizing it to population. So we can say that 1.414 is an estimate of population parameter, right? So in the what is a population parameter? The population parameter is the real, actual, true relationship between education and wage. And 1.41 is an estimate of that parameter, right? So let me not go into that much theory, otherwise this will become an econometrics class, which I don't want to take. So let me interpret this number. It means that if education rises by 1 year, so if somebody has one more year of education, it will lead to an increase in wage equal to 1.41452 units. So if wages are measured in thousands of dollars, then it will be 1.4 thousand dollars. That means $1,400. So every additional year of education leads to an increase in wages on an average by $1,400. That is the meaning of this 1.4145. Similarly, for experience, another year of experience, one more year of experience, for each additional year of experience, on an average, leads to a rise in wages of 0.17871 thousand dollars. So multiply by thousand, $178 per month, right? So this is the interpretation of these coefficients, and that's how regression coefficients are interpreted. So when you write a paper, you have to report these coefficients because they capture the impact of that particular variable on the dependent variable. Yeah.
Sir, can you repeat the last how experience and wage has been interpreted here? $178. Can you repeat it like how you interpreted it?
Okay. Okay. Uh, education or experience? Which one?
Sir, experience one, sir.
Experience. Okay. So for every additional year of experience, on an average, wage rises by $178.71,
Okay, sir. Okay, sir.
right? Because I multiplied it by 1,000 because wages
1,000.
might be in thousands. If wages are in lakhs, I will multiply this by lakh. If wages are
Lakhs.
in hundreds, I'll multiply this by 100, right?
But for education, it is number of years.
Now again, uh, although no, see, it has this is an okay. Let me interpret it once more so you get a clarity. So for every additional year of education, wages rise by 1.41452 thousand dollars. That means $1,414.5. So again, I am interpreting this number in terms of dollars, not years, right?
Dollars. Okay, sir. Okay, sir.
So all the coefficients will be interpreted in terms of dollars because the dependent variable is wage, and if it is measured in thousands of dollars, then these coefficients will be interpreted in thousands of dollars
Got it, sir. Yes, sir.
in the units of the dependent variable only, right?
Yes, sir.
So that's how we interpret these coefficients. Now come to the standard error. Okay, let me allow you to ask questions on this if you have any question in mind.
So the explanation that you put forward right now, it depends on how the dependent variable, in this case wage, is what is the unit of measurement, right? If it's $1,000, you said it has to be multiplied by 1,000,
Yes,
right?
yes.
Acha. So it's not something like percentages that we do, isn't it?
No, not percentage.
Hmm.
It has to be interpreted in the units of the dependent variable.
Hmm. Okay.
What is there in terms of the residuals? A minimum quartile and then median,
Okay,
yeah?
so let me explain that also.
And if
Uh,
you could see the estimated mm, regression line versus the actual data or something, if that's possible.
your voice is feeble.
Okay. Can you
Yeah,
hear now? Sorry.
yeah. Now I can hear.
Yeah. So if we could see the estimated wage function vis-a-vis
Okay,
the actual data. Yeah.
okay. We
Thanks.
can. Yeah. These residuals. You want me to explain the residuals? No.
These are the residuals, right?
Yeah, these are
Yeah.
the residuals, and this is the minimum of the residuals, and this is the first quartile, median, third quartile, and maximum of the residuals.
Okay. And where does the R square appear?
R
Okay, it's
squared,
there.
yes,
Adjusted R square is there.
yeah.
Okay. Okay.
No, R squared and adjusted R squared both are there.
Yeah. Yeah. Durbin Watson also appears in this.
No, double Watson does not appear here.
Okay.
Only
Okay.
F statistic is there, and the p
Okay.
value of the F statistic is also there.
Right. Right. Okay. Okay. And these residuals, the kind of statistics around the residuals, it will automatically be here
Yeah,
for
this will
for every least square regression.
for every regression. This the format of the output will remain the same in R.
Okay.
Yeah,
So in your formula, that LM,
yeah.
LM stands for least square, OLS.
Linear model. That means OLS only.
Okay.
Yeah.
Okay. Yeah. Thanks. Thanks.
Yeah. LM stands for linear model, and what is done there is ordinary least squares method. So
So
the
one clarification, when we did this age also do have an impact on, right,
yeah,
on the wage that we get, but we found it all NA. In that case, sir, we had used just three variables,
yes,
explanatory variables. In
yes, yes.
that case, it's coming like that. So
Mm.
in our research paper, though, we don't restrict ourselves to just two, three variables. We
No,
use
no,
in,
no,
uh,
no.
so
You
in
can.
in yeah, in that case, if this trouble occurs,
How will you
because we know
troubleshoot?
that is, yeah.
Okay.
So that's why can we switch to now PLFS data? Like you have shown one with this thing, wage function and all that. Because so the
Yes.
data that you have given, na, that is as a wage function,
Hmm.
how are the units measured? How do we check it out that? Because I saw the raw data that you have given us.
So here
And hmm,
there must be some explanation of these numbers. When you have your data, you must be knowing that in what units the wages are.
right, because over here too we can't
Yeah.
see what
You
units are
can't
there.
see.
That's
Here
why I
you can.
wanted to use the PLFS data. So in that case, I think it will
Okay.
be more defined and all that thing.
Okay. We'll use that now. Any other question? Okay, in the meantime, this R squared and adjusted R squared, these are also important measures, and they measure the percentage of variation in the dependent variable that has been successfully explained by the independent variables. So this can be any value between 0 and 1. Now here it is 0.27. So 27% of the variability in the dependent variable wages has been explained by this model. So it is very low actually. So R squared is very low. And then we have significant t statistics. So again, this model is questionable on many grounds. I have not even checked the assumptions here, right? So once you run the regression, things are not done. There are certain things which have to be done after regression, checking for model assumptions and all those things, right? Like heteroscedasticity, multicollinearity, autocorrelation, uh, normality of residuals, all those things have to be checked. So, so what I wanted to say here is that there are other things that have to be done. It's not the end of everything because, uh, and we have to see many things here uh, before coming to the conclusion that what we have done is right. Okay. So before moving to the PLFS data and doing a regression there, okay, let me see again. I will not include age uh, because it got the NAs. I didn't see that is there anything wrong in the age because it is created data. So there might be something, multicollinearity might be there, which we can check using variance inflation factor. But I don't want to go that far ahead right now, so I didn't do that. But still, I want to add some more variables here and see what is happening. Then I'll show that estimated regression line, and then I'll go to PLFS data. So we don't have much time, but I'll do it quickly. So experience, and then let me take education, experience, age, female also, female and non-white, two more variables. And now I'll see, let me call it model wage 2. And now I'm saying model wage 2. So this is the model wage 2. You can see that R squared has improved. So now 32% of the variability in wages has been explained by this model. We got all the variables significant again. Let me tell you how to interpret this minus 3.14. So it means that uh, the the category that is coded as 1 has 3.14 units as a wage, 3.14 units less than the category that is coded as 1 as 0, right? So what is coded as 1? Female is coded as 1. So females have a $3.14 lower wage on an average than males, right? Similarly, I can interpret this coefficient minus 1.4 because of the minus sign, again I will interpret it as lower. So non-white wages are 1.46 units less than white wages, white people wages on an average, right? And these are also significant. Why do we have 2 stars here? Because you can see the p-value is not uh, very close to 0, but it is 0.004. If this is less than 0.05, there will be a star here. There will be 2 stars here. If it is less than 0.01 or 1%, there will be 3 stars. If it is less than 0.1, there will be 1 star. If it is more than 0.1, there will be no star, and then that particular variable will not be significantly affecting the dependent variable. So we will not interpret that, or we will conclude that this particular variable which doesn't have star here, not even a single star, we will conclude that that particular variable does not affect the dependent variable, right? So a few more things that I clarified. Again, here this is a better model than the last one because it explains more variability in wages as compared to the last model where it was 27% and here it is 32%, right? Okay. Next thing is to show the line, right? For that, we have to use the ggplot, and we will do wage education. Uh, the data is my data, and I am putting wage on the y-axis because that is the dependent variable, and I am putting education as the explanatory variable, and I am looking at the regression line uh, that can explain this relationship, and I'm doing geom point. Let me do geom smooth, and run it. So it is a curve actually. Let me do one more thing, geom point also, and in geom smooth I will write method equals linear model. So this will fit a line and it will show the data also. So if you don't want the data, you can remove this geom point, or you can make the point small, maybe size equals 0.2. And also this standard error which is shown around the line, if I want to remove it, standard error equals false. This will remove the band, which is the confidence interval band around the line, which I don't want. So I'm removing that by writing this additional argument. If still the line is not visible clearly, so I can make the line a bit wider. So that's the line. Okay, we don't have much time, so whatever time remains, I will do one regression using the PLFS data. So I think I saved it as HH level, right? So let me write names HH level. So it shows these variable names. So what regression do you want? Sushma, you can tell me. What should be the dependent variable?
So can we show the? So yesterday I was talking about this labor for female labor force participation.
But it,
Female wage, is it possible to do that in
no,
that
it's
data?
not. That female data is not there in.
Oh, but personal level, right? Is a household level data you're saying?
So, but you can do it yourself. So,
Uh,
tell me one of the variables which are already here. So, let me say that.
so how can religion also we can say affects the income or household expenditure or social group
Okay.
type?
So, let me take expenditure, consumption expenditure as the dependent variable. This one. So, model expenditure and starting with the linear model and first writing the dependent variable. Okay, it's taking. It will be difficult. My data equals. Sorry, data equals HH level. Right? Is it HH level? Yeah, HH level. Now I'm writing the dependent variable. Is it showing? Not showing. So difficult to type it. Let me copy it. So I'm Control C and then Control V. So this is the dependent variable tilde, and then explanatory variables can be. I have to
We
copy
can
them all.
size, type, religion, social group.
So let me take household size plus household type plus religion.
So household expenditure is dependent variable, right?
Yes.
So we are doing plus sign. Okay, okay, sir. Tender sign. Okay, sir.
So I've taken three variables: household size, type, and religion, and then I'm writing data equals HH level, and it is done. Summary, model exp. So here is the summary. What we see here is that for 1 unit rise in household size, the consumption expenditure rises by 1065 rupees because it is positive, so it rises, not falls. When the household type changes from 1 to 2 to 2 to 3 to 3 to 4, so then the consumption expenditure falls by 344 units. And when religion changes from 1 to 2, 2 to 3, 3 to 4, on an average, whatever the change is, 1 unit change, that leads to a rise in household consumption expenditure by 526.73 rupees. And all of these are statistically significant because there are low p values. The R squared is very, very low, 10% only. So it shows a poor model fit. The p value of the F statistic is very small, so it's a significant model. But again, low R squared is a concern here. So we can't completely trust the model. We have to see the diagnostics and all those things to confirm that we are doing it right and there are no problems in the model, because many a times the assumptions are not met and the model is actually not right and not good. We have to do some data transformations and we have to include or exclude some variables, etc. But we have done it randomly, and we have no reason to believe that household expenditure will depend on household size, but actually it depends on other things which are not even available in the data. So we cannot choose whatever variables we want in the regression and expect that the model will be right. So the model has to come from theory. So you if you know the theory that okay, this affects that, this is already established, so you can take those independent variables which are apt for that dependent variable in the. Any question on this?
So when we say this religion, when it changes the religion from one to another, the household expenditure increases by 526.73 points, right?
Yeah,
So when I say religion, that means you're talking of the reference category, right? In this
I'm
case,
talking. I'm talking about because I did not create dummy variables here.
wait.
I should have created dummy
So,
variables
mm,
where if there are 9 religions, then I should have created 8 dummy variables, one for each
right.
religion, and then we could have got the effect of particular religion on consumption expenditure.
Because these as such doesn't make any sense because
No, this
religion
doesn't make
changes
sense.
what, right? So when I
This
say
doesn't.
religion changes, but what kind of religion? Am I
Yeah,
changing
this
from Hindu
this
to
this
Islam
definitely
or Islam to
does not
Christianity or
make
what?
any
Yeah.
sense because you cannot
Hmm.
put religion and you cannot put 5 7 numbers there and they are representing the religion. We should have
So
dummy
that,
variable
yeah,
for
that
each
means there
religion.
is a need to is
Yes,
it data
yes,
transformation and all that
yes,
thing, creating dummy variables.
yes,
Just because
definitely.
we have the data, we can't just go and do this
Yeah, no,
regression thing and
we
all
can't
that.
do that. Even after doing that, we have to
Hmm.
see the diagnostic tests, and even if they are not right, we have to correct those things also.
Diagnostic तो आज नहीं हो पाएगा. It's already 9:07, I guess.
हाँ, diagnostic टेस्ट तो नहीं हो पाएगा, but I just showed you that how can you do regression and what do the result output mean. Making more sensible regressions, it's an art and there are a lot of things to consider. Not that straightforward.
So is it possible to
Yes.
show some diagnostic test tomorrow in tomorrow's session? Since we couldn't
Yeah,
cover it in today's session.
yeah, I will show that. I will show.
Hmm. So
So
actually,
about
that's why I was trying to use this PLFS data. Just just getting extracting secondary data won't help you out because you have to do a lot of
Lot of work
beforehand.
is there actually. Lot
Work
of
is
work.
there. Yeah, yeah, yeah. That's why I was.
It's not that straightforward.
Yeah, the way it is
Today,
presented. Yeah.
today we barely scratch the surface of regression, and
Yes, sir.
we cannot go understand it deeply until we do it repeatedly and look at all the aspects and one by one and get to practice everything.
So I request you to hold another workshop where you will deal with this kind of secondary data only and the kind of makeup that is required to do before analysis if it's possible. Like another 70 workshop you can do for solely dedicated to this, data
Regression.
analysis and yeah, regression, logistic regression, diagnostic tests and all that thing.
Okay, okay, we can do that if people are interested in that. uh,
Yes.
because what happens in case of R is that most of the people they are in the phase of learning R, or they don't know R. So how can you just directly go and start regression?
I understand, sir. So
So
since
the first
we did our foundation course, so this
yes.
time it was easier. Some of the participants who did your foundation
So
five
the
days or
first
I don't know
step
which day.
is learning R, and then comes the second step where we do statistics in R. For that, we should know how R works. So in this workshop, we got a fair understanding of how it works, and if you devote some hours for practicing it, you will get a hold of it better and better. And then, of course, now in this, you are in a position to understand what is written on your screen, what we are doing. So now we can do a workshop like that. But again, the problem is that if I advertise that type of workshop, people might not join it because first they need to understand R. Even if they join, on the first day they will be asking me to talk about R, how it is done, how that is done. So the
I
whole
understand, sir.
The whole
So my
population problem.
suggestion, so you ask this feedback form every time. So my suggestion would be to, sir, segregate people. You always ask people, na, what is your knowledge of our rank?
Yes,
Preliminary one, two, three, to segregate the participants as and then conduct the sessions like that. Because otherwise, those who have already done your course, it becomes a reputation for them, right? Some of
yes.
the participants are like me and somebody else also was speaking on that terms. For some who are very new, I also knew at one point of time, so I also had these questions that some of the participants were having. So that is a suggestion I'll put up to you, sir, as when you conduct your next workshop.
Okay, I'll see to that. I'll try to do that. Okay, what about others? Any question?
So about the meaning of the result, though the dependent variables are highly significant, but you mentioned that our square, gesture square is very less, like 10% fit
Yeah,
of the model. So we can't consider this model.
yeah.
So, uh, but it is highly significant. How this like possible?
So this is
Yeah.
this is an indication of something wrong here, fishy. That you got highly significant variables and you got a low R squared.
So we
So
can't
something is
depend it
wrong.
on level of significance. We can't depend on level of significance.
No, no. I mean, let me put it like this. If you are getting significant result, statistically significant variables, and at
Okay,
the
sir.
same time you are getting low R squared, it means that something is wrong.
Okay, sir.
So we have to diagnose the problem, that
Okay, sir.
where it is going wrong. And in this case, I am there is no, I mean, no need to even go with this type of regression, because I just put randomly these variables into a regression and I ran the regression. They actually don't make sense, right? Those who are students of economics must be knowing that consumer expenditure does not depend on household size and household type and religion, but it depends on other variables which are far more important than these. Those have to be brought into the model. Then they will be able to explain variability in consumer expenditure. And then we will have a high R squared as well as significant independent variables. And then we will make some sense out of the question, right?
But yes, sir. If I'm wrong, correct me. For logic regression, R square does had in like weightage significance, because I'm getting confused. Mine work was what I was currently working on is logic model.
You are
So
using logistic regression in your work.
yes, sir. And the R
Okay.
square is yes, 18.18%
So in case of logistic regression, the situation is different because the dependent variable is a dummy variable.
Yes, sir.
Right?
Yes,
It's a categorical variable. So
yes.
in that case it is understandable, but here it's not understandable. There is
Okay,
no, you don't have any way to explain this.
absolutely, sir.
Yeah.
Okay, sir. Okay, sir.
Any other question? Anyone? All right. So let us stop here, and we will continue tomorrow. Whatever questions you have, please note them down. You can ask me regarding regression, even any theoretical thing also. Uh, I'll be happy to answer and do a few things. So thank you so much. See you tomorrow.
Thank you so much, sir.
Thank you, sir.
See you
Thank you,
tomorrow.
sir.
Thank you, sir.
Thank you,
Thank
sir.
you.